So whenever you talk about heat, you have to talk about what? Thermal energy. Many people think that thermal energy and heat are the what? Again, just like displacement and distance, they are not the same. They are related. Just like, for example, gravity acceleration and gravity forces. Force. They are not the same, but they're closely related. Same thing with thermal energy and heat. So let's talk about the basic one first. Thermal energy. In any substance in the universe, by the way, do you remember what I said from the chart? This chart, whatever. Yes, this chart right here. Do you remember what I said in this chart about thermal energy? It's never what? It's the only energy of any object that could never go down to what? It's impossible to have what? Could an object have EK of 0? EK of 0. Yeah, when it's what? When it's what? V equals 0 or no motion. Could it have an EG of 0? Yes, when it's where? On the ground, not the ground. Remember the Yoda problem? Nope. Exactly, when it matches with whatever reference height you choose. Again, remember the trick. Technically, most of the time, our reference height is the what? But does it always have to be that? No. However, if we say that, what if I say that the desk is the reference height and I put the tablet here? Now, how much EG does it have? 0. But if I take this one to be the reference height, would it have an EG 0 here? No, because if I move it and then leave it, what's going to happen? Okay, good. Could it have a chemical energy of 0? Yes. If there is no what? If there is no energy stored in the chemical bonds, or if it could not be broken. Any energy could be 0 except for what? Why? Because particles never stop what? Moving or vibrating. Perfectly. So particle are always in a constant. Yeah, you're absolutely. That's why it can be 0. But then you wouldn't have matter. You would have what? Pure energy. Remember, E equals mc squared is only realized then and there. So constant state of motion. Go ahead. Constant state of motion. Sorry for the big handwriting. Constant state of motion. No matter how much you cool something down, particles, protons, neutrons, and electrons could never stop vibrating. They could almost stop, but they will never perfectly stop. They stop, they disappear. Think about it. They stop, they disappear. Okay. Their motion could be one of the following. Okay. Very small, very small vibrations about a specific location, such as in a what? Which state of matter everything is held tight and barely moves? Solid. Thank you. So very small vibrations, very small vibrations about a specific location, such as in a solid. Okay, let's relax it a little bit. Let's make them vibrate and move more. What do you go to? What's less solid than a solid? Liquid is the second state of matter. So what we can say, I know, not intense, but mediocre. What does mediocre mean? Medium, medium, mediocre. They even have the same beginning of the word. Mediocre. Vibrations and a lot of movements or small movements. So if they vibrate and they also could what? Could move small, such as in a liquid. Last one has to be a what? Solid. Liquid must be what? So in a gas. And what are we going to say? Intense vibrations, which means the vibration happened at a high frequency. So intense vibrations and large motion. Large motion. What's up? Okay, again, is plasma really important to understanding the physics we need? No, plasma is what? It is super, super hot. And there's also what? Super, super, which is called Bose-Einstein condensate. These two things are called Bose-Einstein condensate. It's advanced physics. That's why I didn't mention it, okay? It's named after Bose, who's an Indian physicist, Einstein, who's the German-Swiss physicist, and you don't have to know it, all right? Okay, so the next slide has a diagram to it. It basically kind of like illustrates the difference between solids, liquids, and gases for most part. Okay, so let's go to the next slide. Gases, no, sorry, solids usually come with what? crystal structure. Crystals basically means what? A geometric structure. And they also have what? They're held together by very tough ionic bonds, usually ionic bonds, restricted vibrations, and they have a high density. Liquids, non-crystal structure, most part. Some liquids have actually what? Crystal structure. Mediocre vibrations, some motion possible, somewhat dense packed. Again, are all liquids have this? Do all liquids have the same density? Absolutely not. Think about it. Water has what? Has an average density of roughly what? Roughly 1 gram per centimeter cube, or 1 kilogram per meter cube. But that's exact water, not exact. I mean distilled. Do you think this is distilled water? Nope. This water has some minerals in it. Okay. Distilled water means what? Pure H2O. Any other water will have some impurities. Right, yeah, exactly. So any other water other than distilled will not have an exact density of what? 1 gram per centimeter cube of it. Okay. Honey. Honey is more what? Sorry, not honey. Can you ever mix oil and water? No way. If you have oil and water here and you put them together, no matter how much you shake it, just leave it for a while. What's going to happen to them? They're going to separate, exactly. And that's one what? That's one important industrial process. The separation of what? Oil and water. Which one is actually always going to be on top? Yes, which tells you what? Which one is more dense, oil or water? Yes, because when you put something and it sinks to the bottom of the river, what does that mean? It's got more density. If it floats up, it's got what? Fewer density or less density. What's up? Go ahead. Okay? Gases are all over the place. Non-crystal, they can't be crystal, otherwise they'd be somewhat in these two. Strong vibrations, which means what? They vibrate a lot, and they even have what? So as they move, they also what? Vibrate. Yes. And finally, they have a low density, otherwise you can't breathe them. Okay? All right. Next. Okay. Now, within a material, the total energy of particles or molecules, I really don't care what they call them, the total energy of its particles or molecules is mainly composed or made up of the following two types of energy. Number one, since they're moving, what are we going to call it? Kinetic energy. Thank you. So kinetic energy. Kinetic, right? Kinetic energy, which is due to the due to the non-stop motion, and vibration within the material. The other one, say again, technically, potential energy. Why potential? Because you've got what? You've got a lot of what? Attraction and what's the opposite of attraction? Repulsion. So potential energy. But what did we say about potential? What did we say about the word potential energy? Does it apply to where's the chart? What did we say about the word potential? It applies to how many of these? All of them except what? Except kinetic. All of these are what? Potential. So when particles move, what potential energy could they still possess? Potential what? Potential chemical, potential electric, potential magnetic. Everything is potential. Yes. Okay, everything is potential. All right? So potential energy to do what? Due to the potential energy due to the consistent, non-vanishing, what do we say? Attraction and, what's the opposite? Repulsion. Some people say repulsion. Some people say repulsion. Depends how you treat the S-I-O-N at the end of a word. I usually say repulge. Attraction and repulsion between particles and molecules because of their electric and, what's the other side of electric? Magnetic. Thank you. Because of their electric. Can you ever make an electron neutral? Do you think you can ever make an electron neutral? An electron by definition is what? An electron is by definition negative. If you make it neutral, it stops being a what? An electron. How can you ever make a proton negative? You can't. It then stops being a what? A proton and becomes some completely other particle. can you ever make a neutron positive or negative? No, no, no. Okay. But then it ceases to become what? By the way, you can always change a particle. Remember, particles could become other things. Neutrons could turn into what? And protons could turn into what? But that's my point. Once it turns, it ceases to become what? Its old self. It becomes a completely new thing. Okay? Magnetic. Attraction. Attract, repel. Attract, repel. Whoa. Repel. Okay? The sum or total, the sum of these two types of energies is what's today's lesson, which is what? Thermal energy is called the thermal energy of an object. Okay, I have a question now to everyone. Everyone, if I take this right here, I'm making tea. So what do you have to make tea? You have to do what to the water first? You have to what? You have to heat it up. Here's my question. Here's my question. When you heat it up, what do you increase when you heat anything up? So okay, what kind of energy increases? Okay, I just told you that the thermal energy is the sum of how many things? Here's my question to you. If you heat something up, if you heat the water inside this up, which one of those would you change? Why not the other one? Can you ever change by heating up? Can you ever change by heating up the electric or the magnetic properties of protons? You only change what? You change their what? Their what? And you never change the what? The attraction or repulsion profile of the material. Now, why did I even mention that, everyone? Because of this slide. What is the definition of temperature? If you heat water up and you have a thermometer, what happens to the reading of the thermometer? It's going what? It's going up. So what exactly are you increasing of water? Are you increasing the potential energy of water or the kinetic energy of water? Exactly. And that's my point. Thank you. Everyone, what's the definition of temperature? Temperature is some kind of what? It's a measure of the average kinetic energy of what? Of particles in matter. You can't say it's an average, it's a measure of the average potential energy. The potential energy of matter never what? Unless you change the matter itself. But if you just heat it up, what are you changing? The motion, right? Which means what? Temperature just tells you how fast they what? They vibrate, or what happens when you cool something down? Are you adding more energy or sucking energy out of it? Exactly. There you go. So temperature is defined to be what? A measure of the average kinetic energy of objects molecule. Actually, I don't want to say molecule because maybe they're not molecules. Maybe they're particles. Let's just say particles. Yes. In other words, if an object has a what? Can someone read this and tell me what should be here? High or low? Why? Because what words are being used? Vibrating very what? And moving. Does that mean they have a low energy or a high energy? How about this one? Low. Okay. All right. So far, so good. Yeah, I know. Yep. check. Oh, my bad. Remember, those two statements above also depend on the what? Nope. State, solid, liquid, gas. These are called the states of the matter. State. Some people like to call it condition. The proper word is state. State of the substance. All right. Heat. Shouldn't you be saying it's the same as thermal energy? Nope, it's not the same. Everyone, thermal energy is how much energy is contained. Look, everyone, right in this, or right inside of this, or right inside of this. I'm awake, that's all I care about. Okay? Or this. What is heat? Heat is the transfer of thermal energy. What does that mean? What does transfer mean? Something gains and something loses. So, question for you, everyone. If I take this cup right, this mug right here. By the way, does this have thermal energy in it? Come on. Is this made of matter? Does matter ever stop vibrating or moving? No. So that means what? This must have some thermal energy in it. Does it have any EK? Not now, maybe now, but the only thing you cannot get rid of is what? Potential energy and what? Kinetic energy. Adding up to what? Thermal energy. I want to take this, and I'm going to put it. Okay, question for you. Feel this. No, just feel the base. Hot, cold. Tell me your sensation. Cold. Okay. If I put it on my hand and teach with it for like 15 minutes, what are you going to feel? Same temperature or warmer slightly? So what needed to happen? Then what did transfer need for it to happen? It needed what? My hand and the cup to what? To what? Contact. Thank you. Heat transfer only happens if you have what? Otherwise, you're going to transfer, right? If you transfer, that means what? You need some what? Touching, contact. I know, some channel of communication, right? So heat is the transfer of thermal energy. Transfer. Some people like to say exchange. I like transfer of. No. Again, what most important principle of energy do we always follow? Conservation of energy, which means even the word exchange and transfer, they really mean the same thing. Because because you're neither losing to the system nor gaining. The whole system is what? Is conserved, finite, balanced. Of thermal. So can you ever say that heat is a property of a single object? No. Heat needs at least how many objects to touch? Exactly. There needs to be some kind of a contact, which means heat can never be a property of a single object. What could be a property of a single object? Nope. Thermal energy is a property of a single object. Every object in the universe has somewhat, has some thermal energy in it. Make two objects touch, both of the thermal energies are going to have what kind of a transfer? Which is, we call what? The top word? Heat. Heat is the amount of energy that flowed between them. So a single object. Okay, it's a process of exchanging or transferring thermal energy between any. Thank you. All right. So let's read this real quick. It's already done and highlighted for you. So thermal energy is the what? Sum of all the electric and magnetic and the what? And the motion and vibration. Possessed, what does possessed mean? Contained within. Heat is the what? Described to what? Transfer of. So, okay. For example, This phrase, a glass of hot water, yeah, a glass of hot water has more what? That's wrong. Because a glass of hot water is how many objects? One. One object does not have heat in it. One object has what? Has, where is it? Thermal energy in it. A glass of hot water has more thermal energy than a glass of cold water. Okay? In most cases in science, it is preferable to use the word heat as a verb. You heat up. You heat up or cool down. What's up? Not as a noun, although we could use it in the context of heat transfer. You might be asked to use a hot plate to heat up to a temperature of 80 degrees. This is the same as asking you to use a hot plate to transfer a thermal energy to 250 milliliters of water. Okay? All right. Okay, everyone, last slide for today. I want to keep all the math to tomorrow. Modes of heat transfer. Modes of heat transfer. Okay? By the way, does anyone know what the meaning of the word mode is? Mode. Yes, mode is basically what? Process or type or operation. So what's up? Could be, but mode. Okay, what does it mean if you have your phone on silent mode? That's a setting, right? So settings of what? Settings of heat transfer. The transfer of thermal energy between two objects or more, but at least you need two, can be achieved in one or more of the following three ways. By the way, there are only three ways of what? Of modes of heat transfer. Three ways. Okay, everyone, listen up. The first way is when two objects physically what? Touch. Thank you. That is called conduction. Conduction. Okay? So conduction, heat conduction, is when two objects physically contact between each other. Like what? Like the ice. Physically, whoops. Physically, I have to what? I have to what? No, I don't have to squeeze. I have to be in what with the ice? I have to contact. I physically have to touch the ice for the heat to flow from my hand to the ice block or cube or whatever. Okay, so that's one. Could you sometimes still transfer heat between two objects without them touching? Yeah, you do. How do you think? How do you think cooking happens? How do you cook in an oven? Thank you. Yes, an air fryer. How does it work? The metal element in the what? In the oven heats up the air, and the air heats up the what? The food, the casserole, the whatever dish you have. Is it making sense? Is the food physically, is the actual food physically touching the actual metal elements at the top of the oven? No, it's not. What is touch? What's the middleman between them? Exactly. You see what I mean? So whenever you have a medium that is transferring or moving the energy from one object to the other, you cannot call it conduction. Does anyone know what we call these kinds of ovens? Which is basically almost every kind of oven ever. Again? Convection. Convection ovens are the what? Are the ones that have are the ones that have gas or liquid between the two what? Between the heat source and the heat receiver. Like basically what? The metal element in the oven and the food. You need a medium. The medium could be either what? A liquid or a what? What? Actually, it's either a liquid or a gas. What if it's a solid? If it's a solid, that means they're touching, which means you go back to what? Exactly. Convection is only when the middle person is what? A liquid or gas. Thank you. All right. Convection. How do you spell convection? Who knows the third mode? Nope. Conduction if they touch. So convection is when there's a middle person, middle thing, middle agent. What's the third one? That's one part of it. What comes from the sun? What kind of energy? Heat and light and the entire spectrum. What is it called? The electromagnetic. No, so you said radiation. The third mode is radiation. Radiation. How do everyone? Do we receive heat from the sun? Are we physically touching the sun? No. Is there physically anything between us and the sun? No, no. Between us and the sun, which is nothing. So yet we're feeling the heat. How? Through the mode of heat transfer called what? Radiation. Thank you. These are the only three ways that heat could go from one point to another point. Radiation. Can you tell me one major difference between radiation and the other two? Both of them have to what? Have to have some kind of a contact. Radiation can travel through what? Okay, hold on. Last slide. We're done. There's nothing to copy. The last slide is what? Whenever you go in lakes or oceans or seas, they have something called what? Convection currents. Convection currents. Now, come on. In your house, everyone, in your house or anywhere, you have what? You have hot air and also what? Cold air or cool air. Which one always floats up? Which one always hot? Why? Because when you heat up air, everyone, when you heat up air, does it condense or spread out? Which means what? Does it become more dense or less dense? What does a less dense thing do? Does it sink to the bottom or float up? Exactly. So everyone, imagine if you heat this up. What happens to this water? What does that mean? It becomes more or less dense? So it goes up. What does it do? It replaces the cold one. The cold one comes down, but it also gets what? So you see what this is called? A what? A water current, because the water keeps what? Keeps flowing from where? Bottom to down. Density is basically the name of the game here.